MS Ramaiah University of Applied Sciences.
Hi students, in this session we'll look into some of the block diagram reduction techniques. Now let us consider this block diagram. We'll use some reduction techniques to reduce this block diagram into a single block diagram where we'll give the same input to the reduced block diagram also, and we'll compare with the same input the response of the system for the given block diagram and the reduced block diagram. Now let's see this block diagram where G1 is given as 1 by S, G2 is given as 1 by S plus 1, G3 is given as 1 by S plus 2, H is equal to 1. Now we'll reduce this G1 and H, which forms a negative feedback system. So if we have to transfer this node to the other side of the G1, then we'll have to multiply a fraction to shift it to this point along with G3. So now we can see we have multiplied 1 by G1 along with G3, which are in series, and at this point G1 and H1 forms a negative feedback system. So after reducing this 1 by G1 and G3, these two are in series. So after reducing, we have G3 by G1 and G1 by 1 plus G1H. Now G3 by G1 and G2 are in parallel. So after reducing, G2 plus G3 by G1 and G1 by 1 plus G1H are in series. So if we multiply these two, we have the reduced block diagram G1, G2 plus G3, where we'll substitute G1, G2, G3 and H in this block diagram. So after substitution, we have this reduced transfer function where s square plus 2s plus 2 divided by s cube plus 4s square plus 5s plus 2 is the reduced transfer function for an input, step input, and the output has to be verified. Now consider this block diagram and plot it in Simulink. Go to Simulink library, go to File, you can see the Simulink library browser, go to File, New, Model. So you can see a window, new window. We'll place the block diagram. So for this, let us consider this block diagram with 4 transfer function blocks. Go to Continuous, select transfer function, drag and drop in the window, new window. So press Ctrl and drag so that we can generate n number of block diagrams as per our requirement. So here we need 4 transfer function blocks. Now we'll connect the 2 transfer function blocks as given in the block diagram. Now go to math operations. We need 2 summers. Select add, drop it in the window, Simulink window. Double click on add. You can see the parameters. So change the sign from plus plus to plus minus. Double click, change from plus plus to plus minus. Go to icon shape, change it to round, apply, OK. Now resize the icon. Now connect the summer output to the first transfer function block, and this transfer function block has to be flipped. So right click, go to rotate and flip block. You can see that the block is flipped. Now connect the output of the block to minus sign of the summer and input of the block to this point. Now connect the other transfer function and output of transfer function 2 to the another summer, and the two summers are given input. Now rename the transfer function blocks as G1, the lower one as H, towards right change it to G2, and on top change it to G3. Now we'll have to give input and output. Go to Simulink library browser, click on sources, we'll select step input. So connect to the step input, go to sinks, select scope, now connect the step input to the positive of the summer and the output of the second summer to the scope. Double click on step input, so change the step time to 0, apply, OK. Double click on scope, go to settings, go to history, deselect limit data points, apply, OK. Close the scope. Now we have the values for G1. Double click on G1. The numerator should remain as 1. In the denominator we have S, so it is 1 space 0. Apply, OK. You can see we have 1 by S as G1. Now G2 is 1 by S plus 1. Double click on G2. Now G3 is 1 by S plus 2. So double click on G3. The numerator will remain 1. In the denominator we have 1 space 2. Apply, OK. We have 1 by S plus 2. Now go to H, double click on H, let the numerator be 1 and denominator coefficient also remains 1, so that is 1. Now save the model. Save. Now we'll simulate this block diagram. Press run. So now the simulation process is started. Double click on scope, auto scale, maximize, so you can see the response of the block diagram for the given block diagram. Now close this window. Now we will use another block diagram, that is the reduced block diagram. So this is the reduced block diagram: s square plus 2s plus 2 by s cube plus 4s square plus 5s plus 2. Go to MATLAB. Now we'll take one transfer function block, change the numerator coefficients and denominator coefficients. So the numerator coefficients are 1, 2 and 2. 1 space 2 space 2. So these are the numerator coefficients. Now the denominator coefficients are 1, 4, 5 and 2. 1 space 4 space 5 space 2. So the numerator and denominator coefficients are done. Apply. OK. Now expand the block. You can see s square plus 2s plus 2 by s cube plus 4s square plus 5s plus 2. Now connect the same input to the step and double click on scope. Go to settings. Number of axes should be changed to 2 since we have 2 plots to be checked. Apply. OK. So you have 2 axes. Now output of the reduced block diagram transfer function has to be given to the scope. Run the simulation. Double click on scope. So we have 2 plots. So if you auto scale, you can see the first block has reached 1 and the output for the reduced block diagram is similar to the given block diagram output. So both are same. Thank you.
At MSR UAS, we spark your imagination unlike any other.